Okay, perfect. Well, everyone, welcome to a very eventful Monday night class. Today is going to be the first day of week 13, where we're going to be talking a little bit about setting up a Django REST API using something called the Django REST framework. So the main thing that we would like to do today is take whatever we have in our wonderful models, which we have again our move model, and we also have our Pokemon models, and take those from just being essentially Django objects or things in a SQL database to being something that an external user can access far more easily than having direct access to your database. So if we go back to uh, when we were dealing with Postgres and SQL itself, and we created Postgres databases on our computers or on Docker servers. The only way that we were able to access those directly was by spinning up a server and then using Python or some other library to directly access the contents of that SQL database. Now, number one, that gives, if you were to only be able to access your database by doing that, um, you would create a bit of vulnerability, to say the least, because then anyone can write a Python script to access your SQL data, and then they can change it and manipulate. Number two, if you decide to prevent that and say, I'm only going to let authorized users have direct access to my database, well, what if there's people who you don't want to have full access to your database? And also, let's be honest, it is not the most intuitive or simple thing in order to connect a Python code to your SQL database using native Python. Lastly, what about if somebody, say halfway around the world, wants to get access to your SQL database, but doesn't want to nor knows how to use Python? What if they're just the only thing they know how to do is use the shell or use Postman? And that is really where Django views and the REST framework is going to come in today. So what REST API essentially lets you do is it lets you transform your existing Django databases or your existing SQL data that's stored through your Django models, and it lets that be accessible essentially by anybody who can make an API call, or another way of thinking about it, anyone on the internet. So we can do that again using the REST framework, where REST stands for a representational state transfer. You do not need to know that or what those terms mean individually, but the Django REST framework overall is a way to design an API that essentially functions to pull data from your SQL database in a slightly more human-friendly format. So because it's a Django framework, it is based very heavily on classes and more specifically models. So while we've been designing our models referring to this models.model class, when we're going to be designing views, we'll be doing that using the view class, which I'll get to shortly. Um, Again, because of Django being a very models-based system, um, everything that we do going forward when we create these APIs, access them, etc., is all based off of our class-based models. So class-based models inform class-based views. Class-based views are then used to facilitate API endpoints that we create. So does anyone recall back when we were first making and playing around with APIs from the internet, what format of data APIs generally return?
JSON.
What is JSON? Like in your own words.
It's a series of, it's like a list of information put in a list format of objects.
List is one way to word it. I would change it slightly and say that JSON is a data format that is essentially a bunch of nested dictionaries at the end of the day. So remember that in JSON, the one benefit, or the thing I really like about JSON, is it consists of key value pairs that are just nested within each other ad nauseum. Now you can put lists inside of JSON, but overall, JSON itself is structured as a series of key value pairs. And that's basically what we're going to be doing today. We're going to take our models in Django and turn them from these abstract SQL tables and databases and turn them into JSON objects of key value pairs. Now, this at its core is relatively easy to do for singular rows or singular items in a SQL database. Because if you think about it, SQL databases or SQL tables are two-dimensional, right? You have a series of IDs going on one axis, and you have attributes for each of those individual primary keys or IDs on the other. So if I take, let's say, an individual object, let's say I have a Pokemon, you can see that the description of the Pokemon here is effectively in the way that it's described by Django's class-based model system. You have a bunch of keys, name, level, date encountered, captured, etc., that correlate to a bunch of values. The values in this case being whatever goes in the character field or the integer field or the date field, and so on and so forth. So what we'll be doing now with these views is taking that sort of correlation that we've developed here and transform that into a actual endpoint that we can access. So the first thing we need to do is we need to do a couple pip installs. So, oh, okay, let's see if I can do this without everything lagging out. The first thing that we want to do is pip install, not requirements again, but we're going to have to install the Django REST, no, I think it's one word, Django REST framework, which is effectively the thing that lets us use the DRF or Django REST framework. Either they're interchangeable. I'm just going to say DRF because it's shorter and easier to say. Once we have pip installed it, whenever you pip install a package that you know you're going to be using, it's always a good idea to pip freeze it to your requirements.txt file. So we've now done that, and I'm going to confirm that it is indeed. Let's see. It should have been frozen. Let's do a pip list real quick. Okay, we'll try that one more time. Okay, there we go. Now it's showing up. It's Django Retro. Okay, so once we've added that, the other thing that we need to do is we need to add Django REST Framework to our list of installed apps, which again, that list goes in the settings.py, which is in your project. So we'll scroll down, installed apps. We don't have a trainer app developed yet, but we will add that later. So we're going to now add in requirements, or sorry, Django. Just double check the syntax of this. So the other slightly annoying thing about Django is you'll have packages that have different names that are differently formatted, how they show up in the pip list versus how they're referred to, as in Django REST Framework, all one word versus DRF, which is also different from how it shows up in installed apps, which is REST_framework. So it's always important to make sure that you keep track of your nomenclature because it will not be consistent, which is one of the only downsides to Django. Okay, so let's go back into our apps. So we'll start off by making a view or basically an API access point for our Pokemon app. So the good thing is Django being Django has already given us a framework for us to do this, which is the views.py application. The first thing that we need to do is, again, just like I mentioned, views are created from classes, just like models are also created by inheriting from that models.model class. We're going to create views using the REST framework. So we're going to import from REST framework dot views. That shows up, perfect. And we're going to import in two different views. The first one we're going to import is called API view. And the second thing we're going to import is called response. So we'll get into what those two are in a second. But essentially, the API view class is sort of similar to the models.model class that we have in our models.py, where it represents sort of a broad framework, one could say, for the model, or in this case, for the API. The second thing that we're importing is called response. Before I say what it means, does anyone have any ideas for what that might be? All right, if not, that's totally fine. So if you guys recall when we had to call things from an API in JavaScript, we often needed to use async awaits. Now, what were we waiting for?
Like the data to populate basically to, oh, the response.
Exactly. Is the exact same thing, roughly speaking, as that. So just again, remember, Django is a REST framework, the DRF is still creating an API. The APIs that we're creating function very similarly to the APIs that you guys have accessed before. So when someone makes a call to your API through the views, which is what we're going to get into, needs to go into your database, fetch the data matching that query. But that data is kind of useless unless you can send that data back to where the API request came from. And that's what the response class is for. So the API view sets up the framework of the API and makes it so that someone can make an API call, but the response class is used to return the data that from your database and send it back to the other side. So let's get into actually creating our view. So the first thing that we need to do is tell Django, and by extension tell Python which table we're trying to access in our database. So given that we're in the Pokemon app right now, presumably we are trying to access the Pokemon model. So let's go ahead and import that. So I'll go to from models, import Pokemon. The next thing that we should do is recall that the Pokemon app is still dependent on the move model, right? So if we go to not the settings and not requirements, we go to our models.py, we see models is not dependent on anything, but Pokemon is dependent on models, or Pokemon is dependent on move. My apologies. So we should also presumably import the move model because the move model is a dependency of the Pokemon model. So we can import that from the move app.models, import move. The next thing that we're going to need to do as well is import yet another Django library called serialize. And we'll get into what this library does in a second. So we'll say from Django.core.serializers, import serialize. And then lastly, we'll import one more thing and then we can start coding. So I will just write a note, discuss what this is shortly. But that will effectively help us in creating responses that can be read by whoever or whatever is on the other side. The last thing that we're going to do is we're just going to import our JSON library. Why do we want to import JSON? Well, everything that we're crafting in our API and its response is in JSON format. So we need to find a way in order to get the data in our database from weird Postgres, SQL, or realistically, move or Pokemon class into JSON form. The way we can do that is by using serializers and the JSON library, but more on that in a couple minutes. Okay, so let's go ahead and actually start crafting our views. Now, the first thing that we want to do is create a class for our view. I think for starters, we're going to create a singular view that returns all of the Pokemon. So this one will most likely not take in any headers or any specific requests, and it'll just, when I call this specific API endpoint, I'm going to get back a list of all of the Pokemon in my model. So we'll call this all Pokemon. Usually it's a good idea to make your view titles as descriptive but simple as possible, because you can have multiple views or multiple API endpoints tied to a single model. And we will not get into that tonight, but that will be a theme showing up in the next few days. So we're creating our all Pokemon class, and this is going to, again, inherit from API. So this is a very similar structure to what we had in the models, where we had a Pokemon class inheriting from models.model. Same way, we have our all Pokemon class that by inheriting from API view, we're automatically telling Django that we're setting up an API endpoint that is going to have some functionality. So the next thing that we need to do is figure out what type of method we are going to assign to our API endpoint, to our view. So in Postgres, can anyone tell me what the names are of a couple of different types of requests that you can make to an API? Or just one name too?
Will you repeat that question, please?
Sure. So what types of requests can we make to an API?
A GET request.
Get request, perfect. That's one of them. Any others that come to mind?
But post.
Those are probably the main ones that you'll usually see. And that's exactly what we're going to be building into our API views here. So if I'm going to define a view that, again, right now the goal is very simple. I want to get a list of all of the Pokemon. Because of that, I'm presumably going to create a get method. Because, again, we're trying to get all of the Pokemon associated with our model. That being said, later on, we will be designing put methods, posts, delete, and a few others. But for today, we're just going to stick with get. But again, the main message the reason I had us go down that little memory jogger exercise is we are designing an API. We are doing it within the Django ecosystem, which means it'll look a little bit weird, but everything that we do in our views is going to be tied to something that we've already done before when accessing APIs. Now think of whatever we're doing here in the exact same framework. So we need to now define our get function, which is going to return all Pokemon in our database to the user/requester. And we'll just do a little pass there. Okay, so let's see, expected indent block, that should go away. So inside our get function, we should probably give it a couple of variables. The first one that we always want to do whenever we define a function is put self in, because that's standard when defining class-based functions. The second thing that we're going to add is the request. So that's also another standard item that we add whenever we're defining a function related to an API call. Is we will add in the request. the request, just in general, because sometimes, again, for certain get methods, or especially for puts and posts, there will be information contained in the body of the request that then informs how you interact with the database. So the general format that we're going to be following is request comes in, take data from request, turn into variables, access data in database, if constraints on data provided in request, apply those, get data back from database, turn data into JSON format, return JSON data as response. So that's the main that's the main format of what we're going to be doing when we create a REST API, or a more accurate way to call it is a RESTful API. I'll just say that RESTful API process. This is a crude generalization, but for our purposes right now, this is about the format that we're going to use. I will also paste this into the Slack channel once we're done. Or I guess, Sean, if you want to do that, you're welcome to as well. So this is also the way that we're going to code our individual methods, including our get method. So the first thing that we're going to do is we have the request coming in that's already included in our get statement. The next thing is we can take data from the request. But if the user's just requesting all the Pokemon, there isn't anything they need to specify. They don't need to specify a specific Pokemon or the way that they want things returned or anything like that. So that doesn't really matter. The next thing that we need to do is item number 3, access the data in the database. So let's write out some pseudocode, or more specifically, let's copy paste this and then turn this into pseudocode. So let's indent that a little bit. No, I did not want to delete everything. So access data in the database, what does that actually mean? Well, in this case, we want to get a list of all the Pokemon in our database. So that's the same item. That's getting the data back. Now we need to turn list of Pokemon into JSON object, and then return the JSON data as a response. Those are the 3 things that our function needs to do. So let's start off with item number 1. Get a list of all the Pokemon in our database. How can I do that solely based on the stuff that I've imported?
You said solely based on what you've imported? What did you say?
Solely based on the stuff we imported, or more specifically, so if you think back to what we did in the Python, in the Django manage.py shell, when creating and updating our lists of Pokemon, that's effectively what we need to do in order to get a list of all of the Pokemon in our database. So would someone like to remind us how we did that in the shell?
Yeah, this is something that has been lost on a lot of us, is the querying. I've been trying to look into it. Is that it would be the data.
Objects dot all.
Yeah, there you go.
Yes, that's correct. So the way that we, again, like you both alluded to, the way that we access all of the rows within a given database or within a given model is by saying model name.objects.all. So in this case, we'll say like all Pokemon equals, so we're going to go to the Pokemon model dot objects. So one option that we can do is dot all. That doesn't actually take anything that we need to order by. However, this is going to just put them in whatever order they're automatically in the database. We can change that by also ordering our objects as they come out, and we can order them by a specific column. So dot all returns everything. The order by returns a specific column. And in this case, just to keep it consistent with the lesson, we have a name column. We could probably return them in alphabetical order. That seems like a nice thing to do. So we'll just order these by their name. So the functions, again, that we played around with in the shell with writing queries and creating individual Pokemon, they will come back to haunt us as we get into developing these APIs because those are all Python commands. So we
Question
are
on querying. When do you use a dot and when do you use an underscore? Because I've noticed some of the commands are underscore, like you have order underscore by, like dot all. So that's been a little confusing because that's like a specific thing you're asking, right? Order underscore by is like you're going to order by something. But in SQL, it was obviously order by with a space.
So it's similar notation to in SQL with a couple of key differences. So this goes back to the way that Python classes work. So the periods are used to sort of delineate sub-methods, right? So here we have, so dot objects, for example, is a property of the Pokemon class. And then, or the order by function is a method of objects.
Oh, got it. Okay. So I'd have to go back, look at the objects documentation within Django to see what methods are in there within objects.
Yes.
Okay, got it.
Now, sometimes it's not doing it right now for some reason, but in general, if the color coding on VS Code were to work, you could generally type something like Pokemon dot objects dot, and none of this is actually, a lot of this is not accurate. But if you type, let's say, O, this would tell you what functions would show up under. Sometimes it doesn't work, but you would want to check that. You'd have to go into the objects documentation. But that being said, the main way that we end up querying or adding new instances of our models is through the model name dot objects and then adding things onto that. But we'll get into how to do some of the other features like making specific queries or changing pieces of database, etc. We will get into that later this week. For today, the only thing we're going to be focusing on is we're one that objects.all, which returns everything in whatever the default order is, and order by, which orders them by whichever column you would like to. In this case, we're going to order them by name. Okay, so this gives us a list of all of the Pokemon in our database. However, do you guys remember what format this list is in? Like what it looks like in the console? Or to backtrack one more step, what form is this probably in JSON format the moment that we return it?
No, isn't it a query set?
It is, or more specifically, it's a list of query sets. So this will return so what format is it? So all Pokemon is going to be a Python list of query set objects. That is absolutely not going to be helpful to us because that is not JSON. So the first thing that we need to do is convert our query sets into JSON. So that's the first thing. In order to turn our list of Pokemon into JSON objects, we need to turn query sets into JSON. The way that we do that is using this module called Django serializers. So what serializers do is, we'll again get into this more in the next week or two, especially when you guys have to write your own later. But what serializers allow you to do is it's a built-in Django feature that turns your query sets into JSON. So we'll define all Pokemon serialized. And that'll be, we're going to run the serialize function on, first we need to specify what format we want to serialize it in, which is the JSON format. And then we need to specify what we're serializing. In this case, we're serializing all Pokemon, which again is a series of query sets. Oh, that's why. It says I import serializers. Should import serialize singularly. And let's see if that Django.core serializers. Okay, that should be spelled correctly. So the other thing that will sometimes happen is when you're making imports in Django, you may sometimes get like yellow squiggly underlines under some of your imports saying that the imports are not recognized or don't exist. That does not affect the running of your code. That being said, it can show up and it can be disconcerting and it will show up as warnings. But in general, if you've typed it correctly, then it should not affect your code. Okay, so we've now turned our individual Pokemon into serializers, or correct, into JSON by using the serializer. The last thing that we should probably do is now return our JSON, return our JSON serialized data as a response. However, the one thing that we should probably mention is that our serialized JSON data still needs to actually be loaded into JSON. So what serializer actually does is it turns it into a JSON formatted binary string. This is not actually JSON. So it's in a JSON format because we told it to put it in a JSON format, but it's not actually JSON. In order to turn a serialized representation into JSON, we then have to load it through the JSON.loads function. So we can say all Pokemon JSON is JSON.loads. And as you can see here, it says that it deserializes a string into a Python object. So we'll load it. We'll take all Pokemon serialized. And finally, this is actually in a JSON data format. The last thing we have to do now is return a response. Again, this is, as we talked about before, the response is a thing that we're waiting for the API to return. Now we're going to return the response of our all Pokemon JSON. So to break down the format that we have here, the request comes in. Okay, can you guys hear me okay?
Yeah, you're back.
Interesting. Okay, yeah, it looked like my entire internet decided to crash for some reason, which was not expected. So when did I cut out?
Oh, there we
Oh,
go.
he's back.
Am I actually back, or is it still being
You cut
funky?
out a little bit, but now you're back.
Okay, this is interesting. Well, hopefully that does not happen again in the future.
You
Yeah,
should
I'm
be
sure.
set up again.
Okay, yeah, that's definitely weird. I have not had this happen before. So it looks like today decides to be a day of as many technical disruptions as possible. So that's fun. Okay. Before we keep trudging on with RESTful APIs, do you guys have any questions about anything that we've talked about so far?
So basically, we've got this view that we've created, which is a Python class that's going to that we're typing in the code in. That's just a query. We put a variable to a query, and then that's going to the serialized is just changing that query into a JSON format.
Mhm.
And then that's what the load is, right? The Pokemon JSON is just loading that. Am I saying
Yeah.
that right?
Yep.
And then we're going to just return that load, and that should be our JSON.
Exactly.
Wow, three lines of code is really all we're really looking at.
In this case, that's correct. It's actually kind of a rare instance
Okay.
in Django where you're importing more than you're writing actual code. But yeah, we're basically only writing 3 lines of code to do this, which is not a bad thing.
Like we would have other ones too, probably, right? Like another class that maybe just outputs, I don't know, all the certain category, or another class that outputs, I don't know, all the trainers associated with the Pokemon, or the other way around, all the so that's why you mean like there would be a lot more, but for
Yes.
each okay.
Yeah. And then also you can design different API endpoints. And actually, here, hang on 1 second. My door is opening for some strange reason.
Then he gets murdered.
Okay,
Oh,
turns out the strange reason is one benefit of staying at families for New Year's, I suppose, which is that open door policies apparently continue to exist. Um, yeah, anyway, hopefully that will not be happening for the next 3 hours. If it does, I think I can chalk that up to some of the technical disruptions. So back over to Django views. So, oh, did the recording also end? Okay, it did not. It's continuing. Good. All right. So back over to our views. So we've got our, again, 3 lines of code for our get functionality of our API. However, we currently, even though we've designed this view, which is great, we don't actually have a way to let Django access these views. So how even though we've created them, sort of like with our Django models, we had to make our migrations and migrate them, but also had to create a database for them to access. Our API views right now is sort of a standalone class that cannot be the API endpoints and views in which do not have access to the real world, or I can't ping them, basically. So in order to do that, I need to set up a URL endpoint that I can access my API through. And that's going to be sort of the next part of what we'll do in lecture. So there's 2 main things that we should do when setting up a URL endpoint. The first one is adding the URL endpoint in our project. And the next thing we'll have to do is also add in the URL and pattern in our Pokemon app itself. So retroactively, I'm just going to add in a urls.py into our Pokemon app. We'll talk about why in a couple seconds. But the first thing that we want to do is tell Django, or to more specifically, tell our overall Django project that we have an API endpoint that we'd like to reference. So the first thing that you'll see here is we're already referencing our admin path. The other thing that we want to do is from our URLs, we also want to import the include module. So we will not talk about URL endpoints a ton today because they can get a little bit complicated and needlessly so for tonight. But all you need to really know is that the path sort of links to, if I can switch over to my browser very briefly, that hopefully everyone can see. So if we take a look at the default endpoint for our Django website, which I haven't spun up a server for or anything right now, but usually it goes to this localhost 8000 port, right? But if you'll recall when I demonstrated the admin panel to you guys, that's then accessible by putting /admin after localhost 8000. how does Django know that after I put the slash admin that I want to visit the admin site? And not, why doesn't it just glitch out and say that a site doesn't exist? The reason for that is if we go back to our URLs, that we've added a path called admin to our default URL patterns, which basically what this line says is if I go to localhost 8000 slash admin to then pull up pull up whatever I have linked to in admin.site.urls. We now have to do the exact same thing in order to link between our URL for our API endpoint that we create and our views.py that we've created to hold them. So one thing to note though is a path cannot link in this case directly to our views. It can only link to the URLs contained in another URLs.py. So think of sort of the Pokédex project, like the project URLs.py, as holding the paths to go to, think of it like the mega nav bar, and then all of the URLs and API endpoints as like subcategories within. So in this case, the first thing we want to do is we want to link our API path. So I'm just going to put in a placeholder, say placeholder API path. And we're going to link that to whatever our URLs are in the Pokemon app. So that's where we need to include, again, which is what I included in the URLs. We want to include whatever URLs are in Pokemon app. I believe it's a .urls. So again, we'll discuss more about what goes inside of this urls.py in the Pokemon app shortly, but the main thing that we're going to say here is, I'll also put a slash. Oh, this is the same thing. If I go to my API path, then do whatever it says to in Pokemon app.urls. And again, the reason that we have to go from the project URLs to the app URLs is because you can't go directly from the project to an individual view. You have to always go from the project to the app, and then from the app, you can go between the app's constituent parts. But in general, you cannot go from the project to a specific thing within an app. So for the last part, let's actually go ahead and make these URLs. So again, the urls.py in the app is a thing that connects our views, in this case, our Pokemon view, to our overall URL pattern. So also, actually, before we do that, let me just change the placeholder path. So in Django, it's generally good format to specify that your API endpoint is accessed using API slash, and then the version number of your API. This is version 1, and then what the API is supposed to be for. So in this case, the API is for the Pokemon app, so we'll say that this is the Pokemon API. So in this case, what we're basically saying is our API should be located at localhost 8000, and then instead of admin, it's now located at API v1 Pokemon. Now, you don't have to call your API path API v1 Pokemon. You could say, this is my API. It's always important to have the slash at the end, though. But you can call it really whatever you want to. However, just for nomenclature purposes and standardization, the general format of your API should be API slash the version number of your API slash what thing your API is accessing. Okay, so let's go ahead now and finally start filling out the connective tissue, which is the urls.py that connects between our views and our overall project URLs. So we can copy some of this stuff. We don't need the admin, but we do need everything after, which, see if we can copy this over. We don't need include, and we don't need any of the stuff currently in our URL pattern. So the first thing, again, this is just the general pattern of our URLs that we're copying over. But the other thing that we need to do as well is link our app URLs to our views. And the way that we do that is by explicitly bringing over importing our views, in this case, our all Pokemon view, from our views.py. So we have from.views, we're going to import all Pokemon. Okay. So before we keep going, are there any questions right now about the views or how they're supposed to sync up to the URLs in our project URLs.py?
I wouldn't even know what to ask at this point. I'm just seeing you cut and paste basically.
These aren't routes, are they?
They're similar to routes, but not exactly.
Okay.
We will get into routing more when we get into React, but these are similar. So basically, we are sort of nesting links on top of each other, which is roughly speaking what routes are, but it's not identical.
Okay. I'll look into that more, man. Thank you.
Okay, so the last thing again that we want to do is connect our URL, connect our views, which again, the views are views turn our API requests into JSON data that then gets sent back. But we need a way in order to let our users or whoever's managing our API connect to our views, which is done by setting up our URL patterns. So the first thing that we want, the only thing that we have left to do is set up a path, just like we set up a path in our URL patterns here to link between our localhost 8000 and whatever is inside firstly, our admin site, or in this case, our Pokemon app. We're now going to create a blank path, which is basically just a default path, that will then get back all of our data from all Pokemon. So what I'm doing in this line is I'm saying, if I access my API path, which is this whole thing, and I don't add anything after, again, because the path here is blank, then return all the Pokemon in JSON format. But how do we return all the Pokemon in our JSON format? Well, presumably, that's going to come from our all Pokemon function, or all Pokemon class. However, we are not going to specify what type of request we want to use. Instead, there's only one request type that this class works with, which is our GET request right now. So we can return this to be as a view, and then specify that the name of our view is going to be called all_Pokemon. So to reiterate how we got to this point, let me first pull up the models, and we'll go, yeah, this might work. So we have created a database in our models of Pokemon that has a bunch of different Pokemon in it. Now, if I would like to go and access the Pokemon that are in our database, I'm going to go to my localhost 8000 / this admin v1 / Pokemon and hit enter. If I do that, then Django will say, hey, I see the link that he's pasted in. The link that he's pasted in matches this API v1 Pokemon format. So I'm going to go into my Pokemon app and tell the app to manage whatever is going on there. We go to the app, and then we say, okay, did he ever add anything after Pokemon? No. So it's a blank path. So I know that he wants me to return all the Pokemon, which is a view. So we're going to return all the Pokemon as this view. Now, what does that view do? We go back to the view, and it says, hey, I know that I got a GET request from someone, so I need to run my for-line function. Firstly, I need to go in and get all of the Pokemon objects in their query set format, which is again the exact same thing we did in the shell. Once they're turned into query sets, I need to serialize them and turn them into JSON for a JSON formatted string. But a JSON formatted string is still not actually JSON. We need to turn that string into JSON by loading it using JSON.loads. And lastly, once it's in a JSON format, I can then return that as a Python response. So essentially, we're going from you type in the URL endpoint of, again, that localhost 8000 / API v1 Pokemon, then Django automatically recognizes that that is a URL that links to the app. The app then recognizes that that links to a view. The view recognizes that you want to run a GET request or a essentially select star query, and then it returns the results of the query in JSON format. Roughly speaking, that is what our view should do. So let's actually test this out. So I'm going to stop sharing real quick. And Sean, do you maybe want to, do you have your database up and running by any chance?
We may have to rerun it because I don't see it in here. Let's see here. La, 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 la. Hmm?
Okay, awesome. So you shouldn't need to make any migrations, but okay, it does look like that's running, so that's perfect. And you've got your Docker up and running, that's good. So now that we've created your URLs, the first thing that I want you to do is type Python manage.py and then run server.
We gotta apply them.
So I would do Control C, and it's probably a good idea to apply them.
Okay, so what was it? Python. I know you said before that you should do them one at a time, but I mean, is it blasphemous just to press enter?
We can try it and see what happens.
Say
Okay, so run Python manage.py migrate.
that again.
So Python manage.py migrate.
Oh, there it is.
Okay,
Hmm.
perfect. And let's see. So now we have two options. We need to populate your database with some data somehow. Because otherwise if it's a blank database, which it looks like it is, and we make a GET request from it, we aren't actually going to get any data back. So in order to do that, do you want to create the data using the shell or using the
I mean, either or, whichever's faster, I guess. But I know we all need practice. Well, I need practice with querying, but I don't know how to do it off my head. I just need practice with it.
Okay, cool. So let's do it in the shell. So in
Okay.
that case, let's enter the Python shell.
Hmm. Oh, why did it do that? Oh, because I there we go.
And let's import your move and Pokemon models.
What was it
You'll have to
from?
specify like from move app dot move models import and stuff like that.
import one of the move. Yep. And then this is gonna be Pokemon. Pokemon app
Mhm.
import. And
Yep.
then I guess the trainer too, huh?
I don't think you'll need to import
All right.
trainer. Let's just stick with those two for now.
Okay.
So, as we discussed at the start, the Move app is not dependent on anything. Like the Move model, it can exist on its own, but the Pokemon model needs a move to function. So, could you open up the models.py for Pokemon and for Move as well? Okay,
Move
awesome.
Pokemon.
So let's go ahead and define a brand new move in the shell. So you can call it whatever you want.
What was it? I guess I'll just go with what we did last time. What did we do last time? Then would just be MOV, and you got to give it a name.
Yep.
Oh yeah, yeah, name.
And everything else are default fields, so you don't need to fill those out. So you can put in
Perfect.
a closing parenthesis and hit enter. And then, do you remember how we save the
Yeah,
data? I just said it. Yeah. So do dot save to put it into your database. And then we're just going to make sure that it got added. So could you could you print out all of the move objects?
either print was it move, right? Move dot objects.
Yep. And then dot all.
Oh,
Perfect. All right, good. So Psychic was successfully added to our database. So generally, whenever I add something, I always just like to print the full database just to make sure that it was actually added. So we're going to do the exact same thing now and add a brand new Pokemon. So to avoid the headache of typing out the whole thing, I'm just going to put a example in the chat once I can find it. That has disappeared. So you can paste it into your shell because you guys have already gone through this multiple times. But if you take a look at the chat, put that in and hit enter. So now we want to save that to the database as well. And then let's go ahead and print out all the Pokemon in the database.
there. It's in there.
Okay,
Right.
awesome. So now we have our Pokemon in the database and our move in the database, but we need to actually link together our Pokemon and our move. So to do that, um, we have two options. Option one is we can link together our Charizard and our Psychic. However, that may cause problems because Psychic and Charizard themselves do not actually exist in the database, right? So, for instance, this guy and that guy are variables that we've created that are instances of our move and Pokemon classes. But if I refer to those are not referring to what is in my Pokemon.objects.all. So what we should do instead is directly link between our Pokemon.objects.all and our move.objects.all. So why don't we create a brand new variable that is going to be the first Pokemon in the Pokemon objects list. So we can call that like Pokemon 1.
What's it going to equal?
That would be, so we can get the first object in the Pokemon list. So let's do Pokemon.objects. This will be the capital Pokemon because it's the.
Okay.
And instead of dot all, we're going to do dot get, and we'll specify that its ID is going to be 1.
So what is this doing? It's doing the Pokemon model itself equals
Yes,
the first Pokemon
exactly. So this
or
is the
the
equivalent
first instance.
of saying, select star from Pokemon where ID equals 1.
Okay, and we're just saving that in a variable.
Exactly. So
Okay.
this is basically the same thing. Now, what you can do is you can also print out Pokemon 1 if you wanted to. And
Okay.
we've confirmed now that that is indeed our Charizard. We're going to do the exact same thing for the first model as well, or for the first move.
Okay.
So
Yes. ID equals 1. Like that, because in the move objects, there's one item in there, and its ID, its primary serial is 1, right?
right.
Primary key.
Yep. Okay. So we've now created our Pokemon and our move. So now we just need to link our Pokemon and move together. So in our models, if we take a look in our Pokemon class, we see that those two are automatically linked. Let's see if I can draw this box over here with our many-to-many field. So what we need to do is we need to add our move, aka move 1, to the list of moves that our Pokemon has. So we can do that by saying, what's the best way to word this? So Pokemon.moves, or Pokemon1.moves, is the full list of moves that the Pokemon has. But right now it doesn't have any moves. So we can do Pokemon1.moves in order to get at the many-to-many relationship. And then we have .add in order to add to that list. And we can add move 1 to that. And hit enter. And now if you want to type out Pokemon1.moves, so as you can see, we now have a very long description that says that we have a many-to-many field that now has a many relate manager object. So that essentially does contain a single move within it. So we've now successfully added to our database, added sample data to both of our databases, and simultaneously have connected our two databases based on that many-to-many key. So let's go ahead and exit the shell. And let's go ahead and run the server. Okay, perfect. So that all looks good. So we have two options, but let's see if this one works first. So can you open up localhost 8000 in your browser?
Yeah. Guess I can just copy this, right?
Yep.
Guess I gotta click on it too.
Yeah, it's either control click or some are alt click. But that'll open it up. All right, so
Mm.
we now get one of our first Django errors where it says page not found. So the reason for that is if we go to our urls.py in the Pokédex project, and if we pop open that error message one more time, we see here that it says Django tried these two URL patterns in this order, either admin or API v1 Pokemon. The empty path, aka localhost 8000 slash nothing, doesn't match either of those. So let's go ahead and let's tack on our API v1 Pokemon. So let's add that to the top after a slash. And take a look at that. That is our GET request. So we have now successfully gotten our Pokemon model to, we've accessed it via this API endpoint, and we've now successfully connected our SQL database back to our browser via this GET request. So again, what we're doing is we're typing in this URL and we're hitting enter. Django recognizes that this URL links to our Pokemon app. And our Pokemon app URLs then says, hey, I know what that URL goes back to. That URL links up with my view. Then our view processes that GET request and returns us that response object. And that JSON response is exactly what you see on your screen. So congratulations. You guys have now successfully created your first Django REST API.
So if we had a path in here with the URL patterns that had nothing like this, it was just blank, and it showed all Pokemon, would that work? So you don't have to put API version 1 Pokemon?
That should probably work. We can try it.
We don't have to make migrations or anything, do we? I could just
So you only make migrations and migrate things when you make
Okay.
changes to your models.
the model, that's right. Okay. So I can literally just delete this, try again, and it should work still.
So also, when you are generally, I would recommend that you stop your server anytime you make changes, because sometimes things can glitch out in the middle because Django might not be able to process all the changes you're making or every time you're saving it and things like that. With that being said, right now, it's probably okay that you've made the change and continued. So if you refresh the page when you go back to the landing page,
Yeah, like that doesn't exist anymore. There you go. Okay.
yep, so that does the same thing.
Sweet.
All right, so here, let's pause the recording for now.